Hello, I'm Joseph. I'm a lecturer in speech technology in UCL, and I will give you a very brief introduction to Python. It will not substitute a more comprehensive course about Python, but it will, in very short time, tell you the very basics in Python. And based on that, you could be able more easily to extend your knowledge in Python to have enough experience to start courses like my course about deep neural networks. So let's assume you don't have any knowledge about Python yet, but you have watched my video about Google Colab and you're able to use Google Colab. One of the most important building bricks in programming are variables. Variables have a name and a content. And if I want to define a variable, for example, here, variable called A, its name is A, I need to give it some content, and the content is 42. In this short example here, I define a few more variables. Another variable is called my number, and that is set to 5. Then house number, and that is set to 2. Whenever I define a variable in Python, I need to give it content. That's specific to Python. I can't just define a variable name without the content. So on definition, it already has a content. The same is true for the next variable. I call that variable silly product. And the content of that variable called silly product is my number times A. So it should be 5 times 42. And finally, I want to see the content of silly product. And that's done by a function called print. So functions are another very important concept in programming. Functions have an output and some input. The input parameter to this function is silly product. It's the only input parameter in this case. Could have more than just one. And print puts its parameters on the screen. Let's execute these few lines of code. That was executed. It doesn't show anything on the screen when I define the variables, but when I call the print function, it puts the content of silly product on the screen, and this is 210. It's my number times A, so it's 5 times 42. For variable names, I can give almost any name to variables. There are a few words that are forbidden. For example, I couldn't give a name called if and else and some specific words that are used in Python, but basically you can give any name to a variable. It's good practice to give meaningful names. So if you have variables only like A, B, and C and longer code, then you will lose the overview quite quickly. So you could give it names like house number. And it's also good practice to have a consistent style. Some people use the Hungarian notation, like here with house number, capital letter for each new word, or you could use underscores to separate words. So especially if you have longer code, don't make the variable names too short, give them meaningful names. So all these variables that we had in this short example are numbers, and they're all integer numbers. And there are different types for variables in Python. So integer numbers are obviously one type of variable. If we go to the next example here, where we define another variable called my house number, it gets a value 42, and that is also an integer number. I can also have numbers with a decimal point. Those are called floating type numbers. So variable outside temperature has a value of 8.3. So it's also a number, and Python is quite relaxed that the first one is an integer, the second one is a floating type. The internal representation in bits and bytes with zeros and one is entirely different, but on the higher level where Python operates, sometimes it allows us to add an integer to a floating point. And let's define a few more variables inside temperature, also a floating type number, and then variable myStreet. And myStreet is a string. String is short for string of characters. I define a string by starting and ending it with quotation marks, or alternatively starting and ending with an apostrophe. Whether I use quotation marks or an apostrophe doesn't matter. It's the same, but if I start the variable with a quotation mark, the string variable, then I need to end it with a quotation mark. So I define also variables myStreet and myCity, and they are the string Wakefield Street and London. And again, I can call the print function. And this time I give it not just one parameter, but 3 parameters. And the print function allows, I think, even an arbitrary number of parameters to hand over. So I handed I'm working in. This is a string that I define right here. I handed my house number, which is 42, and I handed myStreet, it's Wakefield Street. So they're all of different type, but the print function can handle that. And it gives as output, I am working in 42 Wakefield Street. I'm actually working in 2 Wakefield Street. And to just see the content of the variables, I would not always need to print them. In Google Colab, there's that X here where I see all my variables, and I need to make that a bit bigger to see also their values. So here are all the variables that I've defined. I've defined house number of type integer. It has value 2. I've defined another variable called my house number. It has value 42. I've defined a silly product int, and so on. And I also see my string of characters, myStreet. It's a string of 16 characters, and you could count that Wakefield Street, and so on. So let's close that so that we get a full view on the code again. So we can now define variables of several types, and we can call the string function on it. In programming, we want to do obviously some operations on these variables, and the simplest operation are to add or to subtract variables. So in the next snippet of code, I create another variable. It's called temperature difference, and that shall be inside temperature minus outside temperature. So remember, inside and outside temperature were both of type float, both numbers with a decimal point. So we expect that it just gives the difference as an output. I declare another variable called silly sum. I could add my house number and outside temperature. So my house number is an integer and outside temperature is a float. And let's see if that works by printing it. And obviously it works. So Python is very nice to us. It converts this integer to a floating type, and then adds the other floating type. So silly sum will be of floating type. You could look that up here in the X if you want. So let's do another exercise. Let's add my house number and my street. So spoiler, this does not work. My house number is an integer with value 42. And my street is a string with value Wakefield Street. And if I execute that, I get an error message. And error messages are very important that you read them carefully whenever you get them in programming, because it tells you what went wrong. And here it says it's a type error. And here it is a bit more specific. Type error, unsupported operand types for plus. So I have the operator plus. And on the left-hand side, I have an integer, and on the right-hand side, I have a string. And this operator plus does not support of adding integers and string. So error messages are quite useful. If you don't understand error messages like this one and don't understand why doesn't that work, You could copy and paste it and then Google for it. And quite often this will lead you to internet forums where people had exactly the same error as you had. And they will probably give you solutions and help in resolving that error. So next, let's add some strings. I create a new variable. It's called my address. And now I want to put the house number and those strings together. And here I explicitly convert this integer to a string by calling a function called string. So string converts its arguments to a string if somehow possible. You can convert numbers to strings. So my address is now my house number converted to a string plus a space character plus my street plus a comma and a space character plus my city. So let's see what Python does if we use the plus sign between strings. And it simply concatenates those strings. So if we print my address, it concatenates 42, Wakefield Street, and London, and also the space character in between those variables and the comma here. So the plus operator behaves differently depending on what's there on the left and right hand side. It works with strings and it works with numbers. There's one more very important basic variable type in Python, and that is Boolean. A Boolean can either be true or false. So it has one of two values. It's either true or it's false. And I won't go into the details of Boolean logic, but there are basically three functions in Boolean logic. It's AND, it's OR, and it's a negation. So for example, not true would be false, not false would be true, true and true would be true, true and false would be false, true or false would be true. That's the definition of those and, or, and negations. You can look that up in Wikipedia. For the present purpose, we just want to focus that a comparison can either be true or it can be false. So I can make a comparison 5 bigger than 6 and assign the outcome of that variable to assign the outcome of this comparison to variable A. So the content of A shall be is 5 bigger than 6. Now at the moment A is still 42 because I assigned it 42 before as an integer. Don't be confused by that. As soon as I run that code, A will have the content 5 bigger than 6, and we expect that to be false. I can also test for equality, and that's done by 2 equal signs, because remember, one equal sign is assigning a value to a variable. So I need a different operator to test for equality, and those are 2 equal signs. There's also an operator for inequality, and in Python and many other programming languages, this would be exclamation mark, equal sign, that means unequal, and 2 equal signs means is it equal, yes or no. And of course, there's also smaller equal, bigger equal. And I've created 3 Boolean variables here called A, B, and C. And we expect that 5 smaller or equal to 5, that is true. Is 7 equal to 7.0? Yes, we should think so. That depends on programming language, though. But in Python, that is true. So variable B is true. I could take a look at variable A now, either by going on that X or the tooltip. Does it work? Yeah, so now A is of type bool, and its content is false. So these are the main variable types: Boolean, string of characters, and numbers can be integer or floating point. Let's do a very short snippet of code. So for example, you want to determine what to do based on the balance in your bank account. So first of all, we define a variable called balance, and we give it a value of 100. And then we write some code. If the balance is bigger than 500, then we execute everything that's below the if. And below the if means everything that is indented by 2 space characters. So this if statement here ends basically as soon as something is not indented by 2 space characters anymore. And if this if statement here is true, then it will execute all this indented code here. If it is not true, then it will not execute that code. And then we come to the else statement. The else statement is reached if the previous if statement was false. So if this is not true, then else, it will execute everything under the else statement. So in the present example, if the balance is bigger than 500, no, it's not, we just said it's 100, then it goes to the else part and it will print, I'm earning money, and it will increase the balance by 50. So after that, we expect that the balance is now 150 and we can execute this code. And it actually does. So balance is 100, it executes the else statement. So if my balance was bigger, it's 1000, and I execute the code again, then is 1000 bigger than 500? Yes, so then it will execute this part of code, and I've set balance to 1000 because that's bigger than 500. I print I'm shopping, and I decrease the balance by 200. 1000 minus 200 is 800. And then in the end, this is again reached because it's not part of the else statement. It's not indented anymore. So I print new balance and my balance. So that's what I did. I'm shopping, new balance. So these are the very, very basics in Python. There will be a few more videos and Colab scripts about a bit more complex data types, about loops, if you want to do the same task again and again, about how to write your own function. You've already seen the print function, which is very handy. And I think we've seen one more function here, the string function that converts to a string. So programming is a lot about finding functions that already exist so that you can easily use them and don't need to add ones and zeros on the most basic level of a computer, but sometimes you want to write your own function. And I will also briefly cover the concept of classes, and in the end give in the 6th Colab script, give a short introduction on how to load sounds and how to do some basic things with packages and function that you already have in Python and some packages. And you will see that you can do many things with just a few lines of code. So that's it for the first part.